Okay, so let's quickly walk through the Chapter 8 test. First question presented us with this diagram, and it's just basically to see that you've memorized which things are the geometric mean. Again, we can talk about the altitude that was drawn to the hypotenuse, the leg, and the other leg. So in this case, t is the geometric mean of this altitude is the geometric mean of the two pieces the hypotenuse was cut into. So the correct answer is A and B. S, this leg, is the geometric mean of B, the part of the hypotenuse that's touching S, B, and the entire hypotenuse. In this case, I'll go ahead and put A plus B. So the whole hypotenuse is the two pieces together. And down here, this is another way to write this, right? D is the geometric mean of which two values. D is, again, this leg. B is the geometric mean of A, and the entire piece along here, A plus B. Again, later on, you'll be asked to use these, but just memory, do you remember what those were? Next, complete the following special right triangles. We have a 30, 60, 90, and we have a 45, 45, 90, our two special right triangles. If the length of my hypotenuse is 2, the short leg would be 1, and the long leg would be the square root of 3. Remember, in general, it's 2x, x root 3. Over here, it's the 45, 45, 90. Again, my angles are both 45. This has to be 1, and the hypotenuse has to be the square root of 2. Special right triangles. In fact, let me rewrite those here for the next questions so you can look at them. Again, this would be 1, this would be the root 3, this would be 1, and this would be the square root of 2. So in this setting here, it says do not use your calculator. What's the cosine of 30? Well, I bring myself over to the cosine, to the 30 rather, and I know that the cosine is adjacent over hypotenuse, so I'm looking here, my adjacent leg is root 3, the hypotenuse is 2, so I would write the square root of 3 divided by 2. That is what the cosine of 30 is. The tangent of 30 is opposite over adjacent, so I go ahead and write my opposite leg divided by the adjacent leg. That is the cosine ratio. However, that does have a radical in the denominator, and simplified radical form dictates that we shouldn't leave radicals in our denominator. So I can rationalize this denominator by multiplying by root 3 over root 3. This is nothing more than the number of 1. When I multiply by 1, I don't change the value of this, I just change how it looks. So this becomes in my numerator a root 3, and my denominator root 3 times root 3 is 3. So the way that we should write this one, 1 over root 3 is the same as root 3 divided by 3. Looking at the sine of 60, sine is opposite leg over hypotenuse. Again, here's 60, the opposite leg is root 3, and at 60, this will always be my hypotenuse. I'm going to go ahead and write the root 3 divided by 2. And lastly, what's the tangent of 45? I'll put myself at either one of my 45-degree angles. The tangent ratio is opposite leg divided by adjacent leg, so the tangent is 1 over 1, which is equal to 1. Use the following right triangle to find the following trigonometric ratios. Sine G, so if I'm at angle G, the sine would be opposite leg divided by the hypotenuse, so the sine of G is 9 over 41. Oops, 41. Next, I'm putting myself at the angle H here for this one. The sine of H, sine again is opposite leg over the hypotenuse, so I'm going to be writing here the opposite leg is 40 and the hypotenuse is 41. So the sine of H is 40 over 41. Tangent of G, I'm back at angle G. The tangent is opposite leg divided by the adjacent leg. So this is 9 divided by 40 this time. 9 over 40, opposite leg over adjacent leg. And then the cosine of G, cosine is adjacent leg over hypotenuse. So adjacent leg is 40 and the hypotenuse is 41. So there we have the cosine of angle G. Next question asks me to find the length of CT. I'm going to go ahead and put a variable right here. So this is what I'm asked to find, the length of segment CT, which is the hypotenuse. And I'm given an angle of 41 degrees at T, and from this angle, my adjacent leg is 12. Considering the fact that I have my adjacent leg and I'm trying to find the hypotenuse, I'm going to be using the cosine ratio. And what I should write is the cosine of a 41 degree angle is equal to the adjacent leg 12 over the hypotenuse x. My variable's in the denominator, so I'm going to consider this as a ratio, right, and do my cross products. So 1 times 12 is 12, and over on the other side I have x times the cosine of my 41 degree angle. And then to solve for x, we'll divide both sides by the cosine of 41. So x is equal to 12 divided by the cosine of 41 degrees. X is equal to. And the instructions say, please round your answer to the nearest hundredth. When I evaluate that on my calculator, the answer that I get, 12 divided by the cosine of 41 to the nearest hundredth, is 15.90. Again, check with your calculator to make sure you're getting these values. The adjacent leg, and I have the opposite leg as 16 feet. So when I'm dealing with opposite and adjacent, I'm going to use my tangent ratio. So I'll write the tangent of my 47 degree angle is equal to opposite 16 over adjacent. Again, my variable's in the denominator. I'm going to look at this as a proportion. So my cross products are equal. So 1 times 16 is 16, and that will equal x times the tangent of 47 degrees. Dividing by the tangent of 47, I see that x is equal to 16 divided by the tangent of 47 degrees. And then if I evaluate that, I get that 16 divided by the tangent of 47 rounded to the nearest hundredth, is 15.90 feet. Next, solve for x. It's a beautiful quadratic, and I'm just checking that you can still solve by either factoring, quadratic formula, whatever you want. I'm going to go ahead and factor this, and so I'll rewrite it as, let me do this down here. This will become 6x squared plus 7x, and I'm subtracting 5 from each side, and that will equal 0. So we're going to go ahead and factor this. Using my AC method of factoring, the product of A and C, 6 and negative 5, is negative 30, and B, my linear coefficient, is 7. Again, the goal is to find two numbers that have a product of negative 30. When I multiply, I get negative 30, and when I add them, I have to get 7. The number 30 is 2 times 3 times 5, 2, 3, 5, and sometimes I would actually use the factor of 1 too. So I'm playing with 2, 3, and 5, trying to see how I can get the number 7. I know that one of the numbers will be negative because I have a negative product. And when I look at it, the 2 and the 5 together will give me positive 10, and if I subtract 3, that's 7. So I'm going to be looking at negative 3 and positive 10. Again, these have a product of negative 30, and they have a sum of positive 7. Since my leading coefficient, my quadratic coefficient, isn't 1, I'm going to go ahead and split the middle term. So this will become 6x squared, and instead of writing 7x, we're going to split it. And again, the purpose of this was to figure out how to split it up. So I'm going to write this as minus 3x plus 10x. Notice that's exactly 7x, so I haven't changed the value or changed this equation, and that equals 5. Next, we're going to deploy factoring by grouping. So I'm going to look at my first two terms, and then I'm going to look at my second two terms, and I'm going to factor out the greatest common factor in each case. Considering the first two terms, I have a GCF of 3x. I'm going to factor out the 3x, leaving me 2x minus 1. And in my second two terms, over here I have a GCF of 5. So I'm going to factor out the 5. So this will become plus 5, and I'm left with 2x minus 1. Notice I now have a common binomial factor of 2x plus minus 1. So I'm going to factor out the 2x minus 1. I'm going to bring it out in front. And when I do that, what I'm left with is my 3x plus 5. So in here I have a 3x plus 5 left over after I factor out the GCF. Again, zero product property tells me if I'm multiplying two factors and I get a product of 0, the only way that's possible is if one of them is 0. So I'm going to let each have a turn. 2x minus 1 could equal 0. That would tell me that x has to equal positive 1/2. And if 3x plus 5 was equal to 0, that would mean that x would have to equal negative 5/3. So those are my two solutions, 1/2 and negative 5/3. And you'll get the exact same answer if you use the quadratic formula. Let's move on next. Okay, so now we're going to see if we can solve equations involving an altitude drawn to the hypotenuse. So here, again, there's three statements that I can write, and it would relate to this altitude or the two legs of the original right triangle. I know that this is the geometric mean of x and 10, y is the geometric mean of 20 and 20 plus x, and z is the geometric mean of x and x plus 20, or 20 plus x, the whole thing. So let's go ahead and do this for the 10 first, because I think we can solve for x. So I'm going to write down that 10 is the geometric mean. 10 is the geometric mean of, and the two segments are x and 20. So 10 is the geometric mean of x and 20. That means that my diagonals, I have 100 is equal to 20x. Therefore, x has to be dividing by 20 on each side. X has to equal 5. So I now know that x is 5. And I'll write that here also, x is equal to 5. So I can proceed with the other two statements. The next statement, let's go and solve for y. I know that y is the geometric mean of, and the piece of the hypotenuse that touches y is 20, and the whole hypotenuse is 20 plus 5, or 25. So that means that y squared is equal to 500 if I multiply 20 times 25. And taking the square root and simplifying, that y would equal 10 root 5. And as a decimal approximation, that would be about, I'll round to the nearest hundredth, 22.36. So I know now that y is 10 root 5. And then let's do the for z also. Same exact thing as with the other leg, y. Z is the geometric mean of 5 and the whole thing 25. So I'll write that out. Whoops, not y. Z is the geometric mean of the piece that's touching it, the 5, and the entire length, 25. That means that z squared is equal to 125, I believe, 5 times 25. And then taking the square root of both sides, we get that z, simplified radical form, is root 125, or 5 root 5, which is a decimal approximation, is 11.18. Oops, 11.18. So I'll go ahead and write the 5 root 5 right here. Next, find x round to the nearest tenth. No angles are involved. It's very straightforward Pythagorean problem. I know a leg squared plus the other leg squared, 11.2, x squared plus 11.2 squared is equal to the hypotenuse squared, which is 16.7 squared. And just go ahead and simplify this a bit. I get that x squared is equal to 16.7 squared minus 11.2 squared. And then if we take the square root of each side and just consider the positive root, because or principal root, because this is the length of a side length, it's not going to be negative, x would equal the square root of 16.7 squared minus 11.2 squared. And when I evaluate that, I get that x has to be rounded to the nearest tenth, 12.4 inches.